Hello everyone, this is Prem Kumar Karthikeyan. I am from Biomedical Engineering at Sri Kanmova College of Engineering and Technology. Today we are going to discuss about the electrocardiography. The electrocardiography is nothing but an instrument that records the surface potentials associated with the electrical activity of the heart. The functional blocks of clinical electrocardiograph machine there are production circuit, lead selector, calibration signal, preamplifier, isolation circuit, drive and right leg circuit, driver amplifier, memory system, microcomputer, recorder or printer. This is the functional blocks of electrocardiography. From the sensing electrodes, we can able to put into the amplifier production circuit. If the lead fail detector is also there to detect the lead fail, and then lead selector, we can able to select the multiple leads from lead 1 to V6, and then there is an auto calibration with the help of one MVV charge. We can able to auto calibrate the machine, and then the preamplifier can able to increase and amplify the lower energy signals, and then the baseline restoration, the right leg driven circuit, and then right leg electrode, and then there is an isolated circuit, and then driver amplifier, and then analog to digital converter that is known as ADC. With the help of this ADC, we can convert the analog signals into the digital signals in the memory, and then driver amplifier to the recorder or printer. In that, there is an isolated power supply to power the machine, and then there is a microcomputer. This is the major CPU of this electrocardiograph, and then the control program, ECG analysis program, operator display, and then keyboard and the electrode and printer, they are full for the display items. Functional blocks of electrocardiography. Production circuit includes production devices so that the high voltage that may appear across the input to the ECG machine under certain conditions do not damage it. Lead selector. Each electrode connected to the subject is attached to the lead selector of the ECG machine, determines which electrodes are necessary for a particular lead and connects them to the remainder of the circuit. The connections for the central terminal are made here. This block can be controlled by operator or by microcomputer of the electrocardiograph in automatic mode. It selects one or more leads to recorder. In automatic mode, each of the 12 leads recorded for duration 10 seconds. Calibration signal. A calibration signal is nothing but one MVV calibration signal is momentarily introduced into the electrocardiograph for each channel that is recorded. Preamplifier. Preamplifier is nothing but the input preamplifier stage carries out the initial amplification of the ECG. This stage includes very high input impedance, and then the stage should have high CMMR. The CMMR is nothing but common mode rejection ratio. We will discuss in the next slides. A typical preamplifier stage can be a differential amplifier that consists of three op amps as shown in the figure. A gain control switch is generally included as part of this stage. Isolation circuit. Isolation circuit contains a barrier to the passage of current from the power line 50 to 60 Hz. For instance, if the patient came in contact with the 120 V line, V is nothing but an voltage. This barrier will prevent the dangerous currents flowing from the patient through an amplifier to the ground of the recorder or a microcomputer. The isolation circuits are primarily for the protection of the patient in that they eliminate the hazard of electric shock resulting from the interacting among the patient, the electrocardiograph, and the other electrical devices in the patient environment. Right leg driven circuit. Yes, figure can able to show the right leg driven circuit with three op amp. Op amp is nothing but an operation amplifier, and then it is used to minimize the common mode interference. This circuit provides a reference point on the patient that is normally at the ground potential. This connection is made to an electrode on the patient's right leg. Driver amplifier. This amplifies the ECG to a level at which it can appropriately record the signal on the recorder. This stage also carries out the bandpass filtering of the electrocardiograph to give the frequency characteristics as desired. Its input should be AC coupled so that the offset voltage amplified by the preamplifier are not seen at its input. This DC voltage, when amplified by the stage, may cause it to saturate. Also, it often has a zero offset control that is used to position the signal on the chart paper. This control adjusts the DC level of the output signal. Here, EC is the alternating current and DC is the direct current. So we need to convert the alternating current to the DC current. Memory system. We already know that with the help of this ADC, we can convert a analog signal into a digital signal with the help of this analog to digital converter, and then it stores in a memory system. A memory system is a modern ECG machine stored the graphs in memory as well as displayed on the paper chart. If we want to convert into a analog signal means we need to use a digital to analog converter. The signal is first digitalized by an ADC. ADC is nothing but analog and digital converter, and then the samples from each bit are stored in the memory. Patient information entered via the keyboard is also stored. The microcontroller controls this activity. Microcontroller is nothing but one of the brain of this ECG machine, and then it can be act as a CPU of the computer to control every actions in the electrocardiograph. Microcontroller. This controls the overall operation of the machine. In certain machines, preliminary analysis of ECG can be done to determine many vascular factors like heart rate, intervals, and some type of arrhythmias. A keyboard and a display unit help the operator to communicate with the microcomputer. The operator can select several modes of operation by invoking the respective programs. For example, she or he can ask the microcomputer to generate the standard 12-lead ECG by selecting three simultaneous 10-second segments of six frontal plane leads followed by three 10-second segments of six transverse plane leads. Recorder or printer. This provides a hard copy of the recorded ECG signal. This also prints the patient data and other clinical information entered by an operator and the results of the automatic analysis of the ECG. Digitalized ECGs can also be stored in flash drives and DVDs. Problems frequently encountered. What are the problems frequently encountered by the electrocardiograph machine, and then can be able to solve it by the biomedical engineers? There are many factors that must be taken into consideration in the design and applications of electrocardiograph as well as the other potential amplifiers. There are frequency distortion, saturation and cutoff distortion, ground loops, open loops, and open leg wires, artifacts from large electric transits, interference from the electric devices, and the other source of electrical interference. Artifacts. The artifacts can be arises from the many of the factors by the patient movement, and then the noise from the external factors, and then is there any electrical interference from the power lines? These are can able to produce the open loop and open OD wires and then artifact from the large electric transients. The frequency distortions and then saturation and cutoff distortion are the most important problem we frequently encounter in the electrocardiograph. The other source of electrical interference is nothing but any of the electrical appliances is kept nearby the ECG machine, so we can able to produce electrical interferences of our the ECG machine. Thank you.